This is Unit 3, Block 5. We're going to talk here about price elasticity of demand. So price elasticity of demand is usually denoted with the capital letter E. It means the percent change in demand as price increases by 1%. So when we find this value E, it will always mean how much demand went down, the percent demand went down as price went up 1%. There are three terms that you might have heard in your business courses already. Inelastic is when your elasticity is a little decimal between -1 and 0. It's inelastic. It's elastic when your elasticity value is less than -1. And it's unit elastic when elasticity equals exactly -1. So we're going to want to make conclusions about these values and what they tell us. And what you should remember from this is a sentence explaining the exact meaning. I would expect a sentence explaining the exact meaning. So for example, if your price elasticity of demand was -0.4, you would write a sentence saying something like, if price increases 1%, demand decreases 0.4%. That's what that E equals -0.4 means. Notice something here. When E is -0.4, you do not change that to -40%. When you get E equals -0.4, it's already in percentage form. It represents 0.4%, demand going down 0.4%. When that happens, if your price went up 1% and your demand fell 0.4%, you had a larger increase in price than the loss of sales. And that would mean that your revenue increases overall. Your price went up a lot, your demand fell a little, and the result would be that revenue increases. You should raise the price when you have an inelastic elasticity. You should raise the price because it will raise your revenue. As another example, if you have a price elasticity of demand of -1.2, that's elastic. The literal meaning is price increases 1%, that will decrease demand by 1.2%. So it's a little change in the price, 1%. The result is a big drop in demand, bigger than the price increase. This is elastic. And in that case, you should not raise the price because it will result in a revenue decrease. Inelastic, you should raise the price. Revenue would go up. Elastic, you should not raise the price. Your revenue will fall. So now let's get into the details. Those are hopefully things you've seen before in maybe your micro-macro classes. Now we're going to get into the details and how this relates to calculus. We're going to show here how that formula for elasticity is arrived at. You definitely won't have to ever come up with this formula, but I just want to show you how this formula is arrived at. The formula for price elasticity of demand is given here. Q prime of P times P over Q. P is the price, Q is the demand function. So E, as we said above, tells you the percent change in the demand in relation to the percent change in price. And E is defined as percent change in demand, Q, divided by percent change in price, P. To find percent change is defined as absolute change divided by the original value. It's always how much something has gone up or down, how much absolute change has occurred, divided by the original starting value. So for percent change in Q, it would be change in Q, how much absolute change has occurred in Q, divided by the original value of Q. Percent change in P would be the absolute change that's occurred in P divided by the original value of P. All right, so I just took that definition up there and made it a little more technical. Here's percent change in Q divided by percent change in P. Remember, dividing fractions, we have change in Q over Q divided by change in P over P. Another way to write that is change in Q over Q divided by change in P over P. Dividing fractions, recall, you can do a keep change flip. Dividing by fractions is the same as multiplying by their reciprocal. So this can be written as change in Q over Q times the reciprocal, P over change in P. Just doing a little rearranging in the next step. We put the change in Q and the change in P on the left side and the P over Q on the right side. But notice then, change in Q over change in P, well, that is Q prime of P. It's the derivative of the demand function. So this is where our formula comes from for elasticity. Elasticity is always the derivative of the demand function times price over the original demand function. Example 1 says, suppose customer demand for a product is given by this demand function Q of P here. P is the price per item in dollars, and Q is the number of items sold. It says find a formula for elasticity. They mean price elasticity of demand. So price elasticity of demand, E of P, is defined as Q prime of P, the derivative of the demand function, times P, the price, divided by Q, the demand function. First, we need to find Q prime of P. That's the derivative of our demand function. It's an exponential, and it's got a little bit of chain rule going on in that exponent. So its derivative is the original exponential function times derivative of the exponent. There is Q prime of P. Now we have to multiply by P, so times P, and all that is divided by Q. Q is the original Q of P function. So down here in the denominator, I have the original Q of P function. I'm going to do a little simplifying. E of P equals. So in the numerator and denominator, we have a factor of 500,000 that cancels. We also have a factor of e to the negative 0.25p that cancels, leaving just negative 0.25 times p. That is the E of P function, the function that gives price elasticity of demand. You plug in P, price of each item, and it outputs price elasticity of demand. Part B asks us to take our elasticity function and evaluate it at a price of 2.35, and then we'll interpret what it means. So just pulling out our calculator, we're going to plug 2.35 into our price elasticity function. I get a value of negative 0.5875. And we want to write a sentence that does three things. Your interpretation should always do three things. Number one, it should be a clear, accurate explanation of the exact meaning of the 2.35 and the negative 0.5875 and what they tell us about demand and price. Second, you should be clear about whether or not this is inelastic or elastic or unit elastic. And third, you should have an explanation about what would happen to revenue if you in fact raise the price. So let's do that. This is saying at a price of $2.35, if they raise the price 1%, demand will fall 0.5875%. Since our elasticity value, negative 0.5875, is a number between 0 and negative 1, we know this is inelastic. Since the raising of the price, 1% raise in the price, is more than what happened to the fall in demand, dropped about 0.5%, we know we should raise the price because doing so will increase revenue. Part C asks us to do much the same thing. I'm going to leave this one for you guys to try on your own. And then after the video, you can check the solutions posted online to see if you got the same answer as me. And identify the exact price when demand will be unit elastic. Remember, unit elastic means the elasticity of demand is exactly negative 1. So I take my E of P function, I let E be negative 1. To solve this equation, of course, I need to divide both sides by negative 0.25, and we get P equals 4. P is price. This is saying a price of $4 will cause demand to be unit elastic. So what exactly does it mean to be unit elastic? What does that tell us about revenue? Well, it turns out the price that makes demand unit elastic is the price that makes revenue highest. On the previous page, in part B, it asks us to plug in a price of 2.35, and we found at a price of 2.35, demand was inelastic, meaning at a price of 2.35, if they raise the price 1%, revenue would go up. So our revenue function, R of P, at 2.35 is going up. And then in part C, we plugged in a price of 8.46 over here. P equals 8.46. And if you plug that in, you would have found that demand was elastic at a price of 8.46. If they raise the price 1%, revenue would go down. So our revenue function, R of P, would be going down. Looks like somewhere in between, it's going to reach a peak. And in fact, this peak point is at exactly P equals 4 when revenue reaches its highest. Raising the price 1% will result in demand going down 1%. It's really staying flat. Up 1% in price, down 1% in demand. It's flat for an instant. Revenue is flat for an instant. It's at the peak. Lastly, it says now go back to our original function Q of P. The original function Q of P was 500,000 e to the negative 0.25p, where you plug in price and it outputs the number sold. It said use the revenue function and the first derivative test to identify maximum revenue. We're really just going through a different way of finding the highest revenue. Just to let you know, in part D, we use the elasticity of demand function, solve for when elasticity equals -1, and learned because elasticity is -1, because it's unit elastic at price of $4, that is when revenue is highest. So when I do this problem, part E, I am going to find that P equals $4 is when revenue is highest. We're going to do it, though, using the methods that we learned in the previous units, where we use the first derivative test. I'm just verifying we get the same answer. So here we have our demand function. We know revenue equals price per item times number sold. So revenue is price per item times the function Q of P. So R of P is P times 500,000 e to the negative 0.25p. To find the highest revenue, I need to find critical points. So I use the product rule to find the derivative. I set the derivative equal to 0, and I'm going to factor the right side of the equation. That means either this first factor is 0, which is never true. Exponentials are never equal to 0. Or this second factor is 0, which means 1 minus 0.25p is 0. 1 equals 0.25p. P equals 4. There's one critical point at p equals 4. And then I use the first derivative test to see is p equal 4 a maximum, a minimum, or neither. I test the left side. I plug 0 into the first derivative. When you plug 0 into this function, you get a positive derivative value, meaning R of P is increasing on the left side of P equals 4. At P equals 4, R of P is flat because that's where the derivative is 0. And if you plug in R prime of 5, you get a negative value in the derivative. So R of P is decreasing, meaning our R function is increasing, then flattens at P equals 4, then is decreasing, so P equals 4 is a local max, just like we figured out when we used the price elasticity of demand. Now in this particular case, using the price elasticity of demand to find the maximum revenue was much easier. Part D was much easier than doing all of this to find the highest revenue. It just really depends. Having both methods available to you is useful so that depending on the problem, you could use one method or the other.